So we're going to be getting into chapter 4, and we looked a little bit at it last time. Now the homework's been updated. The homework 3.2 is not due tonight. There's more time. I think, let's see, is it due? Let me look. I just changed that one. So 3.2, it's due in 3 days on Friday. So you have some more time for 3.2. And really the thinking on that is that those story problems can be very difficult. So wanted to make sure that you had a reasonable amount of time to get that done. They're not the most, they're not always, as you would say, there's not always a good way to find a direct answer right away. So you have more time to work on those. But I'm going to continue on in the chapter 4, and that's going to be due next week, so that's been adjusted too. And I just want to talk about solving linear inequalities. Now, the thing with these is we're going to solve these pretty much exactly the same way as we solve linear equations, except there's going to be two differences. So it's very similar to solving linear equations. And I'll go through an example right here. Excuse me. So let's say we have this. So with inequalities, we've seen this in chapter 1, and we touched on it a bit last time. We've got these. And what we're going to do is we're going to treat them like an equal sign. So for this class, that's going to mean that whatever we do to one side of the inequality, we're going to do to the other. And we're going to solve for x in the same way as we solved for x when there was an equal sign. So subtract 11 from both sides. And so what we're going to get is x, the inequality we started with, and the number 3. Now, this brings about the first big difference, and it has to do with the answer. So the answer here is not x equals 3, it's x less than 3. So what we really have is this. All the numbers. And what can we say about all these numbers? Well, all these numbers that are smaller than 3. The reason we can say all the numbers, because we're used to seeing say that x equals 3, so that means x was some single unknown number, and then we discovered what it was 3. Well, this is different. X is less than 3. So what's a number less than 3? 2. 2 words. So does 1. 0. -1. -2. -3. In fact, I could just keep going. So it turns out, if I read this, some unknown number less than 3, give me that unknown number. Guess what it is? Well, it's a lot of things. It could be -5, it could be -200.7, it could be -1, it could be 1. So suddenly we get this sort of strange situation where we have infinitely possible numbers. If you go back to what variables are, one thing we did with variables is we would guess some mystery number plus 1 equals 2. So some mystery number plus 1 gives you, let's make it a little different, let's go 3. So if you just had to guess, you could guess, well, I think x being 2, that'll work. And sure enough, it does. 2 plus 1 would give you 3. Same thing here. Guess a number that's smaller than 3. 0, -7. All those guesses there would be valid. So all the valid guesses, those are going to be our answers. So the first difference we have between linear inequalities and linear equations is with linear inequalities, we have infinitely many answers. So x is 3, all the numbers smaller than 3. Now, we tend to represent these infinite answers graphically because it's not just integers like 1, 0, 2, -1, -2. It's also going to be decimal numbers like 2.98. That would also be a valid answer because it's a number smaller than 3. So what we do is we try to represent all these possible answers using a picture. We take a part of the number line that contains 3. Remember with the number line, numbers on the left are smaller, numbers on the right are bigger. So we want all the numbers smaller than 3. Finally, they're actually going to challenge us with a certain type of question. What about the number 3 itself? Well, we said all the numbers smaller than 3. So that does not include 3. 3 is equal to itself. It's not smaller than itself. So we're going to put a parenthesis here saying we don't include the number 3. And this would be a pictorial answer for us. It gives us a picture of all the numbers that are going to go on and on and on that could be our solutions. Any questions about that? Now, there's another thing that comes up. There's another difference. And it's this. What's going to happen is if we multiply or divide by a negative number, we're going to flip the inequality sign. Now, why does this happen? Well, let's keep in mind, when we multiply and divide, we're going to multiply and divide on both sides of the inequality sign by the same number. Again, we're following that pattern we picked up from solving linear equations. So let's start with something like this. -2 is smaller than 5. Well, that's true. Negative numbers are smaller than positive numbers. But let's say we do this. Let's multiply both sides by -3. Well, if we do that, negative times negative is going to be positive. And then 5 times -3 is -15. But there's a problem with this. 6 is not smaller than -15. And you can see this on the number line. So say -15 is way down here. 6 would be, say, right about here. 6 is to the right of -15. Numbers on the right are bigger than the numbers on the left. So this isn't true. This is not true. So we have to fix it. And so we'll write this instead. And that's going to be correct. Now any questions about that? Now let's take a look at another example. Again, -2 is smaller than 8. But let's divide both sides by -2. Well, -2 divided by -2 is 1. And then 8 divided by -2 is -4. But again, we've got a problem. That's not true. 1 is not smaller than -4. So again, to fix it, we have to flip around that inequality sign. And then this is the correct answer. Questions about that? So when you multiply and divide by negative numbers, this is what you're going to have to do. You'll always have to flip around the inequality sign. Now, for everything else, though, you don't flip it. You leave it alone. So there's no change for multiplying So there's no change for multiplying or dividing by positive numbers. So if you divide both sides by 2 or multiply both sides by 2, you're fine. You don't have to switch anything around. You're good. Also, there's no change for adding and subtracting, period. Doesn't matter if you add or subtract negatives or positives. Whenever there's adding and subtracting, doesn't matter what number you're using, there's no change. There's no change for adding or subtracting any number. Any questions about that? All right, so I'm going to do some examples. Let's say so I'm going to do something like this. Now again, we're going to solve for x. So we want to get the x's on the one side. So I'm going to say subtract 12x from both sides. And though I'm making it look like I'm subtracting from the 18x, I'm really subtracting it from the entire side. That's something to always want to keep in mind. Same thing here. It looks like I'm subtracting it from this 12x. I'm actually subtracting it from the entire side. The reason why I put the x's next to each other is just a shortcut type of notation that tells me I'm going to combine those like terms. So I'm only doing it because they're like terms, but in reality, I'm subtracting from the entire side and from the entire side. So if I combine like terms, I'll get 6x plus 45 is less than or equal to minus 8. Subtract 45 from both sides. Finally, divide both sides by positive 6. Now, since I'm dividing by a positive 6, this doesn't change. So x is less than negative 53/6. What is that as a decimal? Just curious. So it's about negative 8.83, rounding off. So this would be our answer, but what this answer says is all the numbers x smaller than this number here, negative 8.83333, if you put it in a calculator. So what that means, we take a part of the number line. I should be careful, it's less than or equal to, not just less than. So all the numbers x less than or equal to negative 53/6. Well, less than, we want smaller numbers. That will be to the left of negative 53/6. And finally, we could be equal to it. So we're going to put a bracket. A bracket says we can be equal to that number. So it's included. Questions about that? All right. Let's see here. Looking for something with a negative. There we go. Maybe a slightly different one. All right, we'll do this. So we're going to get a negative here. Now, we've got these parentheses. Again, just like with linear equations, we're going to, again, solve them the same way, except for those two differences. We're going to get infinite answers, and we're going to get, we divide and multiply by negative numbers only, and multiply and divide only by negative numbers only. That's when the inequality sign switches. But everything else is the same. So if you distribute the -4, and now let's subtract 3x from both sides. Now we could have added 4x to both sides. That might have been easier, but this lets us do something. So we're going to subtract 3x from both sides. Add 8. Now we're going to divide by -7. And because we're dividing by a negative number, this will have to be flipped around. So we'll get x less than -4. Positive divided by negative is negative. So we have all the numbers smaller than -4. So if we draw that, again, we'll draw part of the number line that contains -4. And we want numbers smaller than -4. Well, smaller is always on the left, bigger is always on the right. So the smaller numbers are on that side. Finally, we got to decide, do we include -4 or not? Well, this does not have an equal to. So that means we don't include -4. So we're going to put a parenthesis. The parenthesis means to exclude -4, while a bracket would be including -4. Let's see here. Let's try this. So again, we're going to distribute. That lets us get rid of parentheses. We're going to distribute this minus sign. So we'll get 1 minus x minus 3 is less than or equal to 4 minus 2x. Now, the 1 and the negative 3 we can combine. 1 plus negative 3 is negative 2. Now I'm going to do something a little different. I'm going to add just x to both sides. Then I'm going to subtract 4 from both sides. Now, in this situation, you could deal with this negative sign 2 different ways. You can multiply by negative 1. If you multiply negative 1, you'll get negative 1 times a negative x would be just x. Because when you multiply x by 1, you just get x. And then the 2 negative signs, well, they'll become positive. So that would make x, well, x, what we're looking for. So in that case, let's multiply both sides by negative 1. Smaller. Now, since we've multiplied by a negative, we got to flip this around. So this will be 6 less than or equal to x. So what are we looking at here? Well, if we look at this, we have all the numbers. And what's this thing with all these numbers? They're bigger or equal to 6. Another way you could think of this, 6 is smaller. Ooh. 6 is smaller or equal to all of these numbers. Think of this like a Jeopardy question. And Alex will ask you this question. 6 is smaller than or equal to what numbers? And you would say, well, it's equal to itself. It's smaller than 7. It's smaller than 8. It's smaller than 9. Oh, so this is saying that we want all the numbers bigger than 6, but also including 6 because we've got that there. So when we draw a picture of this, well, where do we find all the numbers bigger than 6? Or 6 is going to be smaller than which numbers? Is 6 smaller than the numbers on the left, or the 6 smaller than the numbers on the right? It's going to be smaller than the numbers on the right. And because we had an equal to, we're also supposed to include 6. Questions about that? So I'll do one more. It's kind of a review question. It's got a trick to it. So how do we deal with fractions? Again, the thing we want to do is we want to get rid of fractions. So we want to cancel all those denominators. And the way to do that is we're going to multiply through by some one number that will cancel the 6, and cancel the 9, and cancel the 18. Now, the reason they cancel is that 6, instead of dividing into x minus 4, would divide into this number. 9 would divide into that number. 18 will divide into that number. And they'll divide evenly. So there's some number that's divisible by 6, divisible by 9, and divisible by 18, and there are no remainders. Now, any number that accomplishes this will work. And there's different ways of coming up with this number, but there's one that comes off the top of my head right away. It's 18 itself. With no remainder. Again, no remainder. Again, no remainder. So we can multiply through by 18, and that's going to cancel these numbers out. Now, this is what happens when we do that. Something does happen other than just cancellation. Six will now divide into 18. And the 6 will go away, but it's going to leave a 3. 9 will go into 18. It's going to leave a 2. Now 18 goes into 18 one time, and it's going to leave a 1, but 1 times 5 will just be 5. So this is what we'll have. And again, because we multiplied through with a positive 18, this doesn't flip. If we had chosen a negative number, this would have to flip. But since we chose a positive number, no problem. So distributing, we'll get 3x minus 12, 2x minus 4, plus 5, -4 and +5, +1. X minus 12. Add 12 to both sides. We'll get X greater than or equal to 13. Questions about that? All right, so just for the sake of time, I'm gonna, well, here, I'll do the picture real quick. We have time for a picture. So we want all the numbers that are bigger or equal to 13. Bigger numbers are on the right. And since we're including 13, we'll put a bracket. Any questions? All right. So we're getting into 4.2. We might finish 4.2 today also, which would be nice. So 4.2, we're getting what are called compound inequalities. And it's basically, think about compound inequalities. We oftentimes talk about them when we have what are called multiple conditions. That's sort of a complicated idea, but we don't just want numbers smaller than 3. We also want numbers bigger than 5. So we would say, for example, I'm going to change it. We're going to do something else smaller than 5. Instead of having smaller than 3 and bigger than 5, let's work with numbers in between. So you want numbers bigger than 3 and smaller than 5. So there's 2 conditions here. We want numbers that are bigger than 3 and smaller than 5. So what group of numbers meets these 2 conditions, bigger than 3 and smaller than 5? And what I'm going to do, for bigger than 3, I want all those numbers bigger than 3. And for smaller than 5, we would have this. So bigger than 3, all the numbers bigger than 3, and they're also smaller than 5. So can you think of a number that's bigger than 3, but also smaller than 5? Well, 4. 4 works. So actually 3.1 4, 4.9, 4.99. Those are all numbers that are bigger than 3, but smaller than 5. So if we draw a picture of it, well, it's all the numbers between 3 and 5. And not including 3 and 5. Numbers between 3 and 5. Or another way of putting it, there's 3, there's 5. Here are all the numbers. And they're bigger than 3, but they're smaller than 5. So because we have two conditions, we're going to have two inequality signs. And we're going to run into different versions of this. And let me show you the other one, actually, that we're going to be working with a lot. Okay, before we get into that, let me introduce something called intersection. So the idea of intersection, think of it as like roads that cross each other. There's a little square that forms that's Main Street. Let's say we're Main Street and First Street cross. And right, Second Street's the real popular one. So Main and Second. Well, we have Second Street, and then you have Main Street. And right where they cross, the two streets overlap. They share the same patch of, well, concrete, essentially. That concrete is part of Main Street. It's also part of Second Street. And so we call that an intersection. They share that patch of concrete. So when we talk about intersection, it's all the objects in common between sets. And we symbolize it using this. What's called a cap symbol. This means we want the intersection of sets, or we want the objects in common between those two sets. So for example, the intersection of 1, 2, 3 and 2, 3, 4. Well, it's the objects that they have in common. Objects found in here and also found in here. So the number 2 and the number 3. So this will be the answer. That would be the intersection of those two sets. Now, what does this have to do with inequalities? Well, let's go back to that first example. We want all the numbers bigger than 3 and less than 5. all numbers bigger than 3 and less than 5. So bigger than 3, that's a condition. Less than 5 was a second condition. So less than 5 would look like this. Bigger than 3 would look like that. So what we can do is this. We can take the intersection of this set, all the numbers bigger than 3, with the set of all numbers less than 5. So I'm going to use that set notation, that set builder notation. All numbers x, we'll use their bar, such that x is bigger than 3. We'll intersect this with all numbers x, such that x is less than 5. So this is condition 1. And this is condition 2. So when we use intersection, it can seem a little complicated, I'll admit. But if we think about it, all numbers bigger than 3 and all numbers less than 5. So this is what we're going to get. The set of all numbers. And what number meets these two conditions? Well, we saw that earlier. It's all the numbers between 3 and 5. Any number between 3 and 5 will be bigger than 3 and will be less than 5. So we're going to have all numbers x such that x is between 3 and 5. Let me fix my little curly brace here. So that's where the idea of intersection comes in. Another way of thinking of intersection, it's where the conditions overlap. I'm going to draw a picture. One other thing I want to mention, I'm going to make a change. Let's make this a special and. There's a reason why I'm capitalizing and. It is for effect, but it's also for a very special effect. We can also think of intersection as overlap. And the symbol for intersection. So what we can do, here's the set. X is bigger than 3. Then here's the set. X is less than 5. Where these overlap, where they overlap is the intersection. And we'll have numbers bigger than 3 in the overlap, but also numbers less than 5. So that's another way of thinking about it. Now, as far as doing these problems, Here, I'll do some more examples. We're going to solve for x the same way we did in section 4.1. But then at the end, we have this extra thing. We want to look for overlap. So first off, we're going to solve for x in each condition. And then we're going to look for overlap. So let me do an example. Again, I'm capitalizing this and. They don't necessarily do this in the text, but I'm doing it here just to emphasize that and's a very important key word. And means intersection. So for the first condition, we'll solve for x just like we did in the last section. So we're going to get x bigger than -2. That's the first condition. So I'm just going to write this off to the side. And then add 1 to both sides. Divide both sides by 2. Be it x is less than 3. So let's restate the problem. We have x greater than -2 and x less than 3. So numbers bigger than -2 and greater than 3. And if you think about where those overlap, what that means is we want numbers between, -3 and 2. I'm just going to draw a picture just to give a picture of what my thinking is. You don't have to do this. But greater than -2, smaller than 3, and then well, there's the overlap. So that's the answer in terms of inequalities. And then an answer is a picture, is a graph. would look like that. Finally, what they're going to ask us to do, and I should have mentioned this in the last section, they might ask us to give our answer in interval notation. So remember of interval notation. This means includes. This is excludes. So in this case, we're not including -1 or 3. So for our interval, we'll not include -2. We'll continue up just short of 3, but we don't include 3. And that's going to be our answer. Any questions about that? Now, one thing I want to mention with interval notation real quick, well, I'll save it for the end. I'll save it for the very end, because we're going to get some infinite intervals. So the lesson from this, a big takeaway, and equals intersection. So and will be intersection. So next to the idea of union. Now for union, the key word here is going to be or. So these two words, and or, are going to be important. They're going to key us in if we're using an intersection or an overlap. Or they're going to key us in to something where we're going to collect everything together. You can kind of think of this as having two shoe boxes, say, of like stamps you collected, and you dump them all into one box. That would be a union of the two boxes. The symbol, it looks like a U, but it's really the intersection cap flipped. So the given example was sets. So 1, 2, 3, union with A, B, C. What we do here is we just dump them all into the same set. And that's it. So with union, we bring everything together. We include all of it. Now, what does this mean for inequalities? So let's say we have this. Let's say we have something like this. Well, again, we're going to solve it like we did before. We're going to solve each condition. So we have two conditions. So for the first condition, two x minus 5 is less than or equal to 11. Well, add 5 to both sides. Divide by 2. And since we're dividing by a positive, there's no flipping on the inequality sign. So that's what we get for our first condition. X is less than or equal to 8. Let's double check this real quick. That means, oh, it's negative 11. I'm sorry, let me go back. That's negative 11. Thinking about this. So it'll be negative 6. Divide by 2. Pardon me. We'll get negative 3. So the problem should be negative 11. Negative 11. Negative 11 plus 5 will be negative 6. Negative 6 divided by 2 is negative 3. Just give you a sec to update your numbers. So x is less than or equal to negative 3. For this condition, solve one, subtract 1 from both sides. Divide by 5. We'll get x is bigger than 1. So now let's restate our problem. We have x less than or equal to negative 3, or x less than 1. So we got to be, this is an interesting one. Because what it says is the number we want could be this, or it could be one of these. Oh, bigger. It's bigger. So we actually have a lot of choices here. We can choose really small numbers, or we could choose really big numbers. So with the or, we get to have it all. Unlike, say, with the and, where we can only take the overlap, with the or, we get to have everything. So what this will be, for x smaller than negative 3, or equal to, so we're going to use a bracket. and x bigger than 1. Now, unlike the and, where we only kept the overlap, with the or, we get everything. We're going to join these two sets together. Excuse me. So for this one, this interval will be negative infinity, negative 3, but include negative 3. This interval, this will be not including 1, but then everything bigger. And then finally, we're going to put these together. We're going to join them with a unit. That's going to be our answer. Questions about that? So there's a special and I want to do, and then that'll be it for today. We'll finish this section up on Thursday. I just want to mention a special kind of and we'll do some more examples on Thursday. And again, 3.2 is due on Thursday. There's a special and problem. Let's say we have this. So x plus 2 is bigger than negative 3. X plus 2 is less than 7. So another way of putting it, x plus 2 is, 2 is between negative 3 and 7. So what we'll do is we can write it like this. X plus 2 between negative 3 and 7. So when we write it like this, how do we solve for x? Well, what we're going to do is we're going to solve for x just as we did in the past. The difference is what we do to the middle, we have to do to the sides. And the goal, by the way, is get x by itself in the middle. We want to get x by itself in the middle. So to get x by itself, subtract 2. But what do I do in the middle? I have to do on all the other sides. Subtract 2, subtract 2. Then my answer is x between negative 5 and 5. Or put another way, as an interval, or as a picture, that's it. Let me do one more example and that'll be it for today. I'll do a tricky one. Let's say we've got this. Now again, we want to isolate x in the middle. So let's subtract 1 everywhere. Now what we're going to do is divide by -2. And again, what we do in the middle, we have to do on the sides. Now here's the thing. We've divided by a negative. So what do you think that's going to do to each of those inequalities? Well, whenever we divide by a negative, it flips them around. So -4 divided by -2 is +2. Then we flip. We have x. -2 divided by -2 is +1. 1 times x is x. Then -2 divided by 4 is -2, but we got to flip this one also. And sure enough, when we flip the inequalities, it makes sense. 2 is greater than or equal to, well, whatever x is, but it's greater than -2. That makes sense with the inequalities like that. So now what we have is an interval. Now, with intervals, we got to be careful. With intervals, we put the smaller number on the left, bigger number on the right. It might even help to actually draw a picture first. So here's our answer with inequalities. On the number line, smaller numbers on the left, bigger numbers on the right. We want all the numbers between these two. Okay. We don't want to include the -2. It's better not include -2. But we do want to include 2. And there we go. So now when we do our interval, this might be a little easier. And that's going to be our answer. So that's going to be it for today. What I plan to do on Thursday, I'll do maybe just a couple more examples, at least one more and or a special and. Then look at how you can get some of these where you don't get any answer at all. Sometimes you don't get any solutions, period. And then we'll go in the 4.3. And that should be it for this week. We'll do 4.4. And then that's it for chapter 4. We'll finish up chapter 4, and then at that point, we got to start talking about a test with the 2 sections from chapter 3 and up through 4.4. So that's it for today. If you have any questions, let me know. And other than that, have a wonderful afternoon.
Goodbye. Have a good day.
Bye.
Thank you. Have a good day.
No problem. Have a great day.